Given question, a 6-cylinder gasoline engine operates on 4-stroke cycle. The bore of each cylinder 80 mm, stroke 100 mm. Clearance volume per cylinder is 70 cc. The speed of 4000 rpm. The fuel consumption is 20 kg per hour. Torque is 150 Newton meter. Calculate brake power, brake mean effective pressure, brake thermal efficiency if calorific value is 43,000 kJ per kilogram. Relative efficiency on brake power basis, assuming the engine works on constant volume cycle, gamma is equal to 1.4 for air.
Let us understand given data. This is the 4-stroke engine and number of cylinders is given 6. So, we will give the notation number of cylinders, that is K is equal to 6. Bore diameter, so it is 80 millimeter. So, for bore diameter we will give the notation D and the standard unit is meter, so which is equal to 0.08 meter. Then the stroke length is given 100 millimeters. So, L is equal to 0.1 meter. Then the clearance volume. So, it is given 70 cc per cylinder. So, for clearance volume we will give the notation Vc and it is 70 centimeter cube. Now, we will convert this into meter cube. So, 1 centimeter is equal to 10 raised to minus 2 meter. So, how to write 70 into 10 raised to minus 2. So, it is from centimeter to meter, but we have to take cube. So, which is equal to 70 into 10 raised to minus 6 meter cube per cylinder. So, this is the clearance volume. Then speed is given 4000 rpm. So, for speed we will give the notation capital N. Then the fuel consumption. So, it is given in 20 kilogram per hour, but the standard unit is kilogram per second. So, fuel consumption, that is also known as the mass flow rate of the fuel. So, we will give the notation m dot f. Now, this 20 kilogram per hour we will convert it into kilogram per second. So, in 1 hour there are 3600 seconds. So, we will write here which is equal to 20 divided by 3600 kilogram per second. So, this is the standard unit. Then torque is 150 Newton meter. So, for torque notation is capital T. Calorific value, that is CV. So, it is 43 into 10 raised to 3 kilojoule per kilogram. And we have to find out brake power, brake mean effective pressure, brake thermal efficiency, relative efficiency when gamma is equal to 1.4. Now, we will first find out brake power. Now, we have formula, brake power is equal to 2 pi capital NT by 60,000, and second formula is brake mean effective pressure multiplied by L multiplied by A multiplied by small n by 60,000. Now, what is the value of small n? So, whenever the 4-stroke engine is given, then the small n is equal to capital N by 2. And when 2-stroke engine, then small n is equal to capital N. So, for this question, we will consider small n is equal to capital N by 2. Now, we will first find out the brake power. Now, value of capital N is known, value of torque is also known. So, we will put this value Bp is equal to 2 pi 4000 into 150 by 60,000. So, brake power, that is known as the output power, which is equal to 62.83 kilowatt. So, its a unit is in kilowatt. So, this is the answer of the first question. Now, we will move to the second, brake mean effective pressure. Now, Bp is, so its a value is known and we have to find out this term. So, value of L is also known, that is the stroke length, and what is the cross sectional area, that is pi by 4 d square. So, the stroke length and area, that is related to the piston cylinder arrangement. So, we have to find out the cross sectional area of the cylinder bore. So it is in circular shape. So diameter of the bore is given. So area is pi by 4 d square. We have to take. Small n is equal to capital N by 2. Now this value is known and we have to find out break mean effective pressure. So we will transfer all these terms to the other side. So how to get break mean effective pressure is equal to BP into 60,000 divided by LAN, and we have to multiply here with number of cylinders K, because this is the formula for single cylinder, but whenever there are number of cylinder we have to multiply with K. So we will take this K. Now break mean effective pressure is equal to, we will put the value 62.83 into 60,000 divided by value of L 0.1, then A pi by 4 into d square 0.08 square, N that is capital N by 2, that is 4000 by 2, K is 6. So its answer is 6.2 into 10 raised to 5, and standard unit we have to take Newton per meter square. So we have to take brake power in kilowatt, L is in meter, area is in meter square, this N is in revolution per minute, and here is the number of cylinders. So when we take all these units, then we will get the answer, because this is the brake mean effective pressure, it is in Newton per meter square. Now we will find out brake thermal efficiency. So its a formula is brake power divided by fuel consumption or mass flow rate of the fuel multiplied by calorific value. Now we have to consider the standard unit. Now brake power we have to take in kilowatt. So I will write its a unit in kilowatt. So it is in the numerator. Now in denominator, mass flow rate of the fuel. So it is in kilogram per second. So its a standard unit is kilogram per second, and calorific value it is in kilojoule per kilogram. Kilojoule per kilogram. Now again I will simplify this. Kilowatt means kilojoule per second. So I will write here kilojoule per second. Now kilogram per second I will simplify second per kilogram. Second per kilogram, and this kilojoule per kilogram, kilogram per kilojoule. Now if we observe this kilojoule getting cancelled, second, kilogram is getting cancelled. So now we will put the value. So this brake power 62.83, mass flow rate of the fuel 20 by 3600. So we have to use standard unit kilogram per second, and calorific value 43 into 10 raised to 3. So its answer is 0.263, but this is the efficiency, so we will multiply with 100. So it is equal to 26.3%. Relative efficiency is the ratio of brake thermal efficiency and air standard efficiency. So this is the Otto cycle. So we will say that this is the Otto cycle efficiency. So we will first find out what is this Otto cycle efficiency. It is 1 minus 1 divided by compression ratio R raised to gamma minus 1. So how to find out this compression ratio? So for that we require clearance volume and stroke volume. For the stroke volume, when the piston moves from the top dead center to the bottom dead center, then there is the swept volume, and this is known as the stroke volume Vs. So how to calculate this? So when the piston moves from top dead center to the bottom dead center, then the length covered is known as stroke length L, and we have to multiply with the cross sectional area of the cylinder bore, which is pi by 4 d square. So stroke volume is equal to pi by 4 d square L. So it is pi by 4 0.08 square into 0.1, and which is equal to 5 into 10 raised to minus 4 meter cube. So compression ratio is equal to this stroke volume plus clearance volume divided by clearance volume. So clearance volume we have to also take in the same unit, that is meter cube, 70 into 10 raised to minus 6. So we will take the 10 raised to minus 4 term as a common term, and it is getting cancelled from the numerator and denominator. So compression ratio R is equal to 8.14. So its notation is R. Now we will calculate the air standard efficiency. So 1 minus 1 divided by 8.14 raised to gamma minus 1. So gamma is given 1.4. So 1.4 minus 1, that is 0.4. So it is 56.7%. So we have to write this answer in percentage by multiplying with 100. Now relative efficiency. So break thermal efficiency is 26.3% and this is air standard efficiency 56.7%. So its answer relative efficiency is 0.46. But we will convert it into percentage by multiplying with 100. So answer is 46%.